Welcome. This is easy3dbiz.com. Welcoming all you zero-point energy researchers, inventors, and also observers. It's time for our weekly load test. Basically, I have the 7 batteries right here. And by the way, the current has increased over the last 4 days since I added the last 2 cells. So basically, they've been running this LED right here continuously. And 4 of these cells have been running for over 3 weeks now continuously. So let's go ahead and take a voltage check. I got everything on a 20 volt scale right here. So I'm going to go ahead and run a voltage check on it right now. So I'll go ahead and connect up the leads. This one here. And connect this one here. Now let's go ahead and take a voltage reading, see how we're doing as far as voltage goes. It's pulling in at 8.34 volts. It's fluctuating only because I'm using a cheap tin-plated lead for the last couple cells. I should be getting more of the original silver wire in about 3 or 4 more days, and then I'll rewire them and put together some better cells. But right now it's holding steady at about 8.32 volts. And that's basically with these 7 cells right here. These are all the zero-point energy batteries. Let's go and take a reading with the LEDs lit up now with it under load and see what we get. And once again, since I added the last two, the current has increased. Okay, these are the LEDs. Let's go ahead and check the load. It's 1.71, 1.72. Now, if you look at my previous videos, it was running at 1.61, 1.62. But right now, she's running at 1.72 under load. And that's an increase in the last 4 days. By the way, you can see the polarity is backwards. You know, I can, obviously, you technical guys know that it doesn't really matter which way it goes. But this is with the LED running right now, 1.72. Nice and easy. And that's under load. Now we'll go ahead and do a couple examples right here of what I can actually power now with these cells. Just besides the LEDs, I have a piezo buzzer right here. This is a piezoelectric buzzer, and it powers this up no problem. So let's go ahead and hook up the piezo. This side here, and this side right here. If you guys can hear that, then it runs the piezo, no problem at all. Let's go ahead and check the piezo under load, see what we get. With the piezo under load, it's 1.87, 1.88, and that's with the piezo running. And so that's not too bad. That means you could stick this out in the middle of a forest, and it would run continuously forever until it corroded itself out, which is basically seems to be what causes it to pretty much die eventually. But I'll turn that off because it's probably driving you nuts. But that's just an example of one load I can put on there. And I've got 5 LEDs right here, and let's go ahead and hook those up. Make sure the polarity is correct. See, it powers up these 5 LEDs, no problem at all. Now, it's probably a bit hard for you guys to see, but I got 5 LEDs here, all easily lit up. So pretty much lights those LEDs up, no problem at all. That's 5 of them right there. So they don't seem to have any problem lighting up. These are really cheap LEDs. You can't really see them that well. And I also cannibalized the flashlight right here. And what I did was I took out the basically the 3 bulbs, or the 3 LED bulbs. Let's go ahead and wire them up, see what we get. Once again, I'm going to make sure the polarity is correct here. I don't know if you guys can see that, but it's lighting up these LEDs on the flashlight here pretty well. But I'll do that. I'll show you that in my next video because I'm running out of time here. So once again, stand by and thank you for watching.